Okay, gang. Happy New Year. I hope everybody's year is off to a great start. I am Dan Stull. I'm one of the faculty members here and also the chair of the board of advisors. I'm joined by Bill Keough, co-founder of the program, also a faculty member and one of our board members, Fabio Ferraretto. And we're excited to kick off our AI in the Modern Supply Chain series. Today's topic, we're going to be looking at inventory data and demand forecasting. The way this thing came about, Bill and I were talking about reasons that companies maybe not making progress in AI. And, his observation was, first, the studies show that a lot of the initial implementations have failed, and that, his experience is that companies just maybe lack a roadmap, that they try to jump in too deep. And what they should be doing is putting together a way to try to generate some quick wins, get some learning in the organization, and really focusing on data and looking at their inventory. Bill's done a lot of work, and I'll read his bio in just a second. He's done a lot of work with distribution companies. So I told him the story about a distribution company that I owned shares in, was on the board, and starting about the time of the big economic downturn, 2008, 2009, what was happening was every year we were losing about a half a point on gross margin. And when we pressed and it was every year for several years in a row, and we pressed the management team, what's going on here? The explanations weren't very satisfying. They didn't seem to make a lot of sense. And so I said, well, let's do this. Let's get Fabio on the line because his team works with this area in this area a lot, just doing some initial analytics. And I've known that they've done a couple of projects where they're able to go in and quickly identify some trends in the inventory data. So that's kind of how we came to this point. Let me do the introductions though. And one of the things I want to say is that, in this program, the people that we tend to have on faculty and certainly the board members are people with deep expertise, right? These are people that have come up through the trenches and they know a lot about supply chain, transportation, and logistics. They've got the body bruises to prove it. So Bill Keough has been a supply chain and IT consultant for over 25 years, working with firms like IBM, Computer Sciences Corporations, and several startups. He's also worked for JSI, an NGO focused on optimizing supply chains for public health and lower and middle income countries. He currently manages his own supply chain consulting firm, Keough Associates, which helps private equity firms improve the performance of their portfolio companies. In addition to the University of Washington, his teaching background includes work with Rice University, the University of Houston, and the Global Supply Chain MBA program at the SP Jain Center of Management, the campuses in Singapore and Dubai. He has a master's degree from the University of Houston. Fabio is a business analytics senior executive working in the field for over 20 years, applying advanced modeling and analytics technology solutions to solve complex business challenges, achieving improved customer engagement and higher operational efficiency, servicing most of the top 100 companies in Latin America. He holds a master's of logistics systems engineering and a BA in construction engineering, both from the University of Sao Paulo, Brazil. Fabio is also a certified lead of analytics and AI from Northwestern University. Fabio developed his professional career inside Accenture Latin America, where he started in 2002. He was one of the first executives in the analytics group back in 2010. He conducted the Gapso acquisition of Accenture by Accenture in 2015, becoming the lead for advanced analytics and data science in the region, eventually leading supply chain analytics for growth markets until 2021. Fabio is the founding partner and CEO of DHAUZ, a Brazilian-based data and AI services and solutions boutique supporting Latin America and US-based organizations in their data adoption journey and boosting AI use by capturing business value. So Bill and Fabio, thank you very much for joining us today. Bill, maybe you can give us the setup. I'm going to stop sharing my screen at this point.
Okay, yeah, great. Well, hi everybody. Thank you for joining. Um, like Dan said, I've been a supply chain consultant for a long time, and when I see the advent of AI and how it can be applied to the supply chain, I mean, this is an immensely powerful technology, to sort of drive new results. And as it is now, it reminds me a little bit of when I was way earlier in my consulting career, and I was working for IBM, and it was when the internet started to become important, right? And so once it started appearing on the front of Business Week, a lot of executives were like, I don't know what this is, but this is something we better know something about. And so we did these workshops where we get like senior executives together and talk about their business. A little bit of it was educative, what is the internet, all that. What are some opportunities for you, that kind of thing. And I remember one time it was with an insurance company in Texas, and the guy said, oh, well, tell us all about it. Okay, great. And so I started to go into, what is it and what are your top challenges and how could we apply this? And the guy goes, stop. And I'm like, okay. And he goes, let me tell you what I want. I want you to web enable everything in my whole company so that I can sit by the pool with my computer and manage the whole company. And I'm like, I'm not sure what to do with that. And I think I see a little bit of something similar with AI, right? Like, here's this powerful tool. You have all these companies, there's crazy valuations. But the question is, what do you do with it exactly? And I think the companies who have a lot of money, who take this broad brush approach, how will we use this to revolutionize the entire business so I can sit in my pool and manage the company? And I think that's maybe not the best approach. What we've talked about collectively is like this technology, people don't totally understand it, maybe who are in the business. And a good way to deploy something like this usually is like, what's a serious pain point here? And could this technology help us improve on that? And let's make an investment. Let's see how it goes. If it works out well, let's do how much money did we actually save? And then you can sell this up the chain of like, look, this is a real thing that's delivering real value for us. And so there are a number of places one could start, and Fabio can certainly speak to that. But one place is around stockouts, around inventory management in general. Because when you have stockouts, right, there are a lot of negative repercussions from this. And I put together a couple of slides that I'll share here. So at one point, I got hired by a private equity firm to go to the Dominican Republic. This was a number of years ago. And they weren't sure what the problem was, but it was like, we're losing customers because they can't get our products. So go fix it. So when I went down there, I took this picture like actually a week after I got there. It didn't occur. It was actually worse than this. And so I'm looking around, I'm like, whoa, I can see part of the problem right here. And so a lot of this, I think, when you think about data accuracy, because AI is great, but I mean, AI is not this clairvoyant thing. Like, you need good data to make decisions, to feed the models. And if you don't have good data, this presents a challenge right out of the gate, right? And in my experience, most of the time, when you have bad data, it's a result of sub-optimized processes. So this was what the warehouse looked like. I went through and, their inventory accuracy was 33%, if you can believe this. So part of it was like, okay, well, what's going on here? So part of it was clearly a data problem. These on the left there, they were writing down stuff on clipboards. And I'm like, okay, not optimal exactly. And I said, well, what do you do with the clipboards? And they said, every couple of days, we give them to the SAP guy. So this was the SAP guy. And he'd get the stuff and he'd enter all of it manually. And then there was another piece of paper where it said digitado, like, I've put this into the system. And so my first question was, if you're giving it to him every couple of days, isn't it wrong by the time he gets it? Other stuff has been put away. And they were like, what do you mean? And so what I did was they didn't have RF. It obviously was not a very sophisticated warehouse, but they did have a good implementation of SAP, the ERP system that their company used to manage the business. And so I got all the guys who were the workers' laptops, and it took a while to say nothing moves until it's transacted in the system. And this proved to be a big improvement over giving it to the SAP guy. However, even that approach, there's a lot of problems with manual data entry leads to a lot of errors, right? People are typing and they make mistakes. And if you put 6 instead of 60, this is a problem, right? And so one of the ideas, to the extent one can get away from manual data entry, that's a good thing. So here are some real world examples of poor data quality. This one on the left was actually from an engagement I did in Iraq. Fortunately, I didn't have to go to Iraq. But as you can imagine, public health systems a little bit less sophisticated than what you might see in a company, but sometimes you see similar problems. And so they were managing a lot of their inventory with spreadsheets. The first thing I noticed was there's no SKUs, which if you don't have a specific number to refer to a specific product right out of the gate, you have a lot of problems. But as you can look here in terms of data quality, like, the numbers here, there's an extra parentheses. This is in English, this is in Arabic. The descriptions are inconsistent. In one instance, they were actually using, how in Arabic, there are Arabic numerals, right? Like we call ours Arabic numerals, but there are numerals that are actually Arabic. And you can see them here on the bottom. They were actually using those. So you can imagine with this how it's virtually impossible to apply AI to something that looks like this. And cleaning up the data is a big challenge. And Fabio will talk about this, I think, but it's one of those things that you've got to do it beforehand. And a lot of this is caused by process, usually. It's process and how the data is captured and used. This is, on the other hand, an example from a large software company. And I've always thought it was interesting when you're a consultant, right? Because you see from the outside, oh, these guys are amazing. But then sometimes when you go in and look, what they're doing is less amazing. And this was an example where they were managing a lot of their services work on spreadsheets. And they had like data warehouses everywhere. But like when you're managing things with spreadsheets, you run into a lot of data problems, right? And so they were having stuff where the start date of the engagement was empty. And so it would default to 1900. They also had a lot of different formats, not formats, but like ideas about how they captured cost, direct cost, total cost, actual cost. Which is bad enough, but when I go to get the definitions, different people would tell me those things mean different things. So all this stuff sort of contributes to big challenges in data quality. And then if you take that and you add it to what does the IT architecture look like, here's a really simple example, right? You got 3 systems and they're not tightly integrated. So you can imagine if there's one data format here, one data format here, maybe this data isn't right, and it's getting passed around like this, you have a lot of business problems. And if you have a lot of stockouts, this could be part of your problem. In reality, no enterprise looks like this. This is what enterprises tend to look like, and this is kind of a mess, right? But you can imagine when you take that problem and then put it in this kind of infrastructure, your data challenges are magnified. And using AI in this situation is very challenging. So my last slide here, like having inaccurate data virtually ensures you either have stockouts or overstocks, right? And the consequences, as everybody in supply chain knows, you lose sales, you have to expedite stuff that you don't have. Your customers are angry because you told them you have it and you actually don't. It damages your brand. You've got to do emergency purchases, right? Where you're usually paying more money, and ultimately it reduces your margins. So being able to improve stockouts using sort of an AI approach has a lot of financial benefits. And this is from some publicly available information where there were some studies performed. But like, if you look at this, reducing stockouts by 30% at a company the size of Walmart, um, I don't have a number for what that's worth, but man, it's worth a lot. And AI solutions can help, number one, kind of clean up the data and then put a framework around using models to try to design a system that's more efficient, that's reducing stockouts, that's reducing overstocks, reducing holding on to products that don't move, that kind of thing. So what I wanted to just do here is just kind of tee up from my experience some of the problems organizations are encountering. And I'll pass it over to Fabio, and you can talk a little bit about how you guys have collectively addressed this and other problems.
Thanks, Bill. Thanks for the intro, man. Guys, happy to be here to share some of my stories with you. I'll fire initially a question to Dan, actually. Dan, how much, imagine that you are like staffing a new AI project, right? With data scientists to develop a model to maybe forecast the demand, let's say something like that. How much time, what's the percentage of time that you think that a data scientist during a project to forecast the demand spend actually developing the model? And how much time do you think that that guy will spend working through data? So treating data, capturing data, enabling the data for him to work on that later doing the model. How much do you think is the split?
Well, it's a great question. It's a little bit of cheating because I know that firms like yours now are pulling models from libraries. So you've already run these analytics, and so modifying a model is one thing. So you're if you bring in the right firm, the person isn't built. Hopefully, you're not paying to have the model built from the ground up. With that being said, and let's assume that we've hired the right firm that has some of these models, has a library of these models, they're going to spend probably 80% of their time
Yeah.
just where is the data, what form is it in, how are we going to get it cleaned up, blah blah blah.
Yeah, it's accurate. But actually, even if you are developing a custom model that you cannot rely on, I don't know, on typical time series models, or maybe one of those more feature engineered models using machine learning and so on, and you are going to develop a custom made model that you need some variable cases there and so on. So it's kind of at least 70%. So it starts on 70%. So at least 70% of the time that a data scientist spend on an analytics engagement that handles with demand forecast, inventory planning, all those things, is at least 70% invested in working through data. So what are the sources? How can I capture? Is this actually representing the phenomena or not? What are the things that actually happened throughout the sales process in a retailer, for example, that are actually being pictured in the data or not, and that we'll have to treat them as outliers or not, and so on and so forth. So I started with the question because the point that Bill makes around if you have a lot of terrible data and you start feeling the pressure of the C-level, which is I need to put AI across the board. I need to address supply chain challenges, and I need to have, as you said, Bill, in the beginning, so a control tower or panel that I need and that I want to use a lot of models there to kind of play with the scenarios and decide, take better decisions and so on. If you start that based on very terrible data, it's like the recipe for like a disaster, right? So this is it. And I'll tell you a story. So we started working with a top two company in US in the market of scooter manufacturers. So they produce electric scooter, electric bikes, things like that. They are top two or three. I don't know right now because this is a project for maybe 2.5, 3 years ago. And they were, the idea was to help them to enhance their data use maturity, to enhance their decision-taking model, methods, and so on. And one of the things that we started looking at was uh, uh, in order to reduce their percentage of returns uh, of products, right? Because here in US is very relevant in that industry, right? And then we start digging into data, a lot of problems with master data, a lot of problems with inventory levels being inaccurate, as Bill said. So in his experience, it was like 33%. In my experience with this company, it was like 35 to 40. So more or less the same level, terrible. And then, I mean, while tracking the orders, return orders from the retailers, sending back products to that manufacturer, we actually realized that the retailer they were shipping the returns into the competitor. Come on. It's like you are not returning for, I don't know, from Walmart or Costco, you're returning from that manufacturer, but actually they're returning to their competitor, which means that you are paying for them to return to you because you typically pay for their shipment and so on, but you are actually not receiving the returned finished product. And then your competitor is actually getting that. And in the end, I mean, it was like 2.5% of revenue that was actually being shipped back into their competitor. It's like crazy, and all of that is because of wrong data. You know, it's crazy. So it can reach certain levels of lack of control or even ridiculous scenarios that you can't even imagine, right? So this is it. This is a real case, right? So it's very important, and I want guys to share with you one slide. I'm not going to share with you guys a lot, but only one slide regarding um, a typical method to develop an AI or a statistic model that we typically try to use in the house here with our clients, so you can take a look and see why the data is actually important. Do you see my screen, guys? Yeah. Okay. So how I mean, this is a 6-step method that we did not created as a whole, but we had kind of tweaked a little bit the some steps in order to make sense for the way that we develop models and develop projects for our clients, right? So it all starts with the ideation of variables and ideation of the model, and to actually build it correctly, you need to have a very good, clear picture about the business problem, and the business decision you are actually trying to influence or to enhance, right? And in that first step, you try to ideate what are the potential variables that are the cause or that influences the phenomena that you are trying to predict. That, and then from that decision, for that mapping, let's say, you go and get data. So you try to understand what are the data sources from where you can capture data and so on. And after that, you do a lot of feature engineering, which is when you combine different variables in order to try to explain better the phenomena that you are trying to predict or to explain, right? And when you do that step, you will realize that a lot of the ideas that you had in the first step is actually trash. You're not going to use it, but some of them you actually will. And that's why we try to push forward the data engineering part until the second half of this method, because it doesn't make a lot of sense for you to build like a data pipeline in order to integrate one data lake into a legacy system to actually capture one data source that you actually don't know yet that you are going to use or not, if it's going to be accurate or not. So this is where we try to balance the spending money building the correct data engineering architecture, but only spending that money with the variables and the data sources that you actually need, right? So this is a very iterative process in the real life, because you ideate variables, you capture data, you engineer some features, then you realize that some of those won't work, and then you take it off, and then take another new ideas and go so on and so forth. After 3 or 4 different iterations of this process, then you go and actually build the data engineer part. And on that data engineering part, you then structure data treatment, clear data cleaning, all the, we have a lot of libraries right now, and probably you guys that are on the call probably will also know a lot of libraries that actually can treat the data for you, can process outliers for you, and they learn using machine learning models, that they learn what they can take off from the data and so on and so forth. And then you go into the modeling and then test the model, do some A/B testing to evaluate the accuracy, and then fine tune it, right? So all of those things depends on basically 2 inputs. The first one is the decision that you have to understand based on the business process, and the second input is data, right? So when you don't treat your data correctly, I mean, the possibility of you not getting the right path and not getting the result is like 90% probably. So, and what I see a lot in the market, and probably Bill and Dan will probably say the same thing. So there are some clients that come to us and say, man, can you build me a data lake? And I ask, what for? And they say, because I need to enter in the data business, let's say. I need to be doing some data, some analytics, some AI, and they don't know even where to apply that. So when Bill says, okay, start with the pain, the most, probably the most critical pain that you guys have on your business, and then from that you derive into a transformational journey and so on and so forth. But you have to do initially some baby steps, and not only on the transformational part of the journey, but also on the data treatment, data capture, and data engineering of the journey also, right? I'll stop here, guys, the sharing the screen. But so I wanted to share a little bit the story behind it with the clients, and how we typically tackle to develop the models, right? But it's very nice to see. I mean, I'm on the field for maybe 20, 25 years. We did inventory planning optimization back in the 2000s, using Excel spreadsheets that was running for maybe 12 hours, 15 hours of modeling, right? And with some parameters using Access or other Microsoft software to support us. And now we are doing everything in Python, everything in using Databricks and other things. So the evolution of not only the computer processing power, but also the kind of techniques that we are using right now is amazing. But it all relates to data, right? It all relates to data.
Fabio, given the fact that the data, I mean, as we've talked about here, having relatively accurate data is kind of table stakes to be able to do
Yeah.
any of this. Maybe you could talk a little bit about like how AI can enable that. Because I know in my own past experience, you'd go to the client, you say, give me a dump of this and this and this, and you look and go, you realize you have the same customer with 8 different names. It's got company, it's got CO, it's got a comma, it's capitalized, it's not capitalized. And, there really are some data cleanup opportunities. And so everybody goes, yeah, absolutely. And it's like, well, who's going to do that? And like, no, nobody wants to do it because it's kind of grunt work and it takes a long time. And be like, I got other responsibilities. And so a lot of times it perpetuates, like the data doesn't get any better. There are some tools and some approaches now to at least make it a lot, less of a lift, right?
Yeah, so LLM made a very huge impact on that, Bill, because it understands very well the context and it compares very well the tokenization of the different characters and so on. And it supports us a lot right now. And here in Brazil, I'm based in Brazil, there is the challenge of the language challenge, as you said, because sometimes the descriptions are in English and the name of the product is in Portuguese. Sometimes the date is in US based, sometimes the date is on Brazilian Portuguese format and so on. So there are a lot of challenges regarding that here. And right now, LLM is helping us a lot. What we are doing right now for some clients is trying to localize the models so it would capture like a GPT-4 or whatever and localize it, regionalize it in a scenario that you don't want to expose your data publicly. So that's a concern on our clients. But then what we typically do is a lot of scripting with the GPT or Grok or whatever the LLM is, and it helps us a lot. And we typically do, Bill, combine LLM with other things or with NLP or other things, right? So I'll give you an example. So we were working with a hospital here in Brazil, and we had to understand or to interpret actually some physicians' prescriptions regarding what are the exam that specifically guy has to do or the patient has to do, or maybe a drug, specifically drug that he has to take and so on. And the problem is that part of so it really ties to the way that the doctor actually writes, right? So it's kind of sometimes you use like I don't know, blood trial, and then sometimes they use like a BT for blood trials or things like that. So this is very tough to treat and to structure because in the end of the day, what we want is to transform as much as we can an unstructured data into a structured data, which is much easier to analyze and to build models around. And it's tough, but with the LLM is a very new approach that the engineers are taking right now. And actually, we in the house we call it the machine learning engineers or the LLM engineers because they are very strong at prompting, very very strong at prompting. And typically, what we do is we build a model with one LLM with a lot of prompting, right? And then we build a second model with another LLM to actually evaluate what the first LLM actually did. So we kind of have like a Q&A between two different LLMs in a way that in the second one is like an agent, gives you feedback from the first model, and from that you can fine tune the first model based on those feedbacks from the second one. This is key for us right now in terms of data treatment and in structuring NLP solutions for clients right now. So LLM
Fabio,
and the combination of things.
what in your experience, right? Like the whole thing of I've got 7 companies where the names are spelled differently. That's easy, right? I mean, an LLM can easily figure that out. And I think if I put 60 instead of 6,000 into something, I would imagine a model can also look at that and go, wow, this is an outlier. I mean, it might be right, but you might want to take a look at this. What sort of data quality problems have you run into where it's like AI doesn't help that much?
Sorry, Bill, I probably didn't get the, because it cut on the, I don't know if I have a very good connection where I am. Can you repeat the question, please? Because it's
Sure,
cut in the middle.
sure. I mean, I think there's a couple things that an LLM is good at, right? The list of company names and saying this is all one company. That's pretty easy.
Yeah,
And if there's an order for 60,000 of something and the normal order is 50, you can go,
yeah,
hey, that
yeah,
could be right, but
yeah.
it's worth looking at. That might be wrong.
Yes, yes,
My
yes.
question was, what sort of data quality problems have you run into where AI like is not that helpful? Like if I
No,
enter 59 instead of 60, there
yeah.
would be no way to know.
So in terms of LLM, man, it's all about text, right? So when we are treating the text data that is actually text is almost unbeatable, the LLM. It do a lot for us, right? But when it comes to reasoning around trends and the combination of trend with external phenomena, and then try to mimic how much of that external variable influences the phenomena, then it's a little bit tricky because uh, I mean, technically speaking, guys, it's like all the LLMs handles with the challenges in terms of tokens, right? And that thing we can have a second webinar around that because it's a very deep and more technical thing. But anyway, and when we come to like quantitative analysis and so on, it's tougher for the LLM, right? And then that's why we try to move into a more traditional machine learning development and combine techniques, right? So Bill, so all all challenges that we handle that involves a specific quantitative forecasting, that involves probability of something, that involves propensity of something, and so on. We are like we kind of run out from the LLM and focus on more traditional, let's say, statistics, and also more uh, common machine learning things or deep learning things, right? And one thing that is like a trend, at least here in Brazil and with the clients that I'm working with, is you build a model, maybe a machine learning model, more traditional, based on numbers and so on, and then you build an agent to evaluate the model. The same dynamic that I told you about having one LLM and then the other trying to measure what the first one did. This thing is a very trendy thing right now. We are getting very good results from that technique. So this is more or less how we are.
Guys, can I
Sure,
go back to my pain point for this
of
company that I
course.
was involved with? No, it's great because it's interesting because our challenge was not stockouts, and in fact, our strategic goal and kind of our positioning in the market was we had the highest fill rate in the industry. Okay, but that meant that we kept a little bit more inventory than we otherwise would. The pain point was every year after the big financial collapse, we were losing about a half a point of margin a year, and the company was privately held, just under $100 million a year in sales. Okay, so if you're losing half a point a year, and we get out 5 years, we're now down $2.5 million going to cover our overhead. So if we don't change our overhead, that's $2.5 million we're losing on the bottom line. huge problem. When we talked about this before, Fabio and Bill, you guys came up with this concept of let's assume that the data, we can get the data clean. It's a big assumption, but you guys were talking about a process where we could give you a snapshot of the data, and Fabio, you and your team could run kind of a proof of concept. And you talked about this idea of being able to do a cluster analysis to try to figure out what was going on in the data, right? Now, fast forward, because again, the management team, their explanations, the other board members were like me, they're kind of scratching their heads like, that doesn't really make any sense. And then they put together a plan. It's going to be much better next year. And then next year, we've lost another half a point. Eventually, after about 5 years, we realized that the trend was because of the downturn, we had been selling about 60% of our volume into independent retailers. But after the downturn, these big chain companies were coming in and snapping up all of the independents. So after 5 years, suddenly 60% of our volume is going to these big chain stores. And what those big chain stores were doing was building their volume, and they were bringing basically the A products inside, right? The high margin, high value products they were doing through their own internal distribution. So increasingly, we found that we were left with the B and C items, the higher volume but the lower margin problems, the lower margin products. And when we talked through this before, that's your cluster analysis would probably be able to have spotted that earlier. Like, hey, you're starting to lose sales in your A products, the high margin products, and you're starting to pick up sales in the B and C products, right? So Fabio and Bill, maybe you guys talk a little bit about how that process might work and how you could talk to an executive and say, hey, even with just a sample of your data, we may be able to do some clustering and figure out what's going on.
Dan, if I could ask, so in that particular instance, prior to the analysis, did you guys think about products as A, B, C? Or, I mean, was that the concept, or it was just like, here we have all these products?
Here we have all these products. Again, very typical of a closely held, people been in the business for a long time. I mean, a great team, smart people, but not the kind of. So no, nobody was talking in terms of A, B's, and C's. We eventually, 5 years on, figured it out. But by then, we're down $2.5 million a year, which is real money. Yeah. Fabio.
So I was while you were describing, then I was like trying to connect with some of the projects that I did in the past. But in the end of the day, it's like every challenge is a challenge, right? And yeah. It typically doesn't. It can correlate, but it won't fit 100%. So this is it, yeah. Right? So so guys, for us now, the power of AI and analytics for us is that it allows you to do what we call like a micro segmentation, right? It gives you a lot of power there, because the ABC that you just mentioned, then it could be ABC in inventory turns, could be ABC in margin, could be ABC in revenues, and so on, is the first kind of highly mature segmentation or clusterization, products clusterization in the market that everybody understands, right? But then when you compare, for example, if you control or does not control the manufacturing of the product, and it changes a lot the environment and the characteristics, because when you control the actual manufacture, for example, of one product, and this product is also an A in volume, but is a C in margin, maybe it's different from the same thing, but when you don't control the manufacturing step of the product, because you rely on a supplier, and then when you rely on a supplier, sometimes this supplier cannot fulfill you, and then you have to add safety stock or to increase your inventory levels and so on. So I give you a very, very simple example in terms of how do you combine different variables in order to further clusterize, not only in volume, but also taking into account other variables to make that clusterization. So right now, we typically address maybe half of the supply chain challenges that we have right now with clients using clusterization, because you then realize that you have to, so and coming back into inventory, right? When you put money in it's like you are investing in inventory, right? You could be investing in other things, but you are investing in product inventory. And then you have to invest when it's where it's right and where you have like a better return on investment. In the end, is all of the all the inventory managers or directors, this is their mindset, right? So in order to make that, I come back into that method that I showed you guys. So first things, ideate. What are the variables that are actually defining a nature of a product which is different from A to B, and then capture data and so on and so forth. So the method is the same, but the solution is different because it's going to tap on inventory clusterization or product clusterization, for example, right?
I think you bring up a good point about the ABC, right? I mean, I've been in places where they don't even do that, like at all. And
Yes,
then there are
yes,
other
yes,
places
yes.
where here's our A SKUs, B SKUs, and it's like volume, right? Or it's velocity. I did a thing one time where we looked at all the inventory for a company and did it by volume, value, and variability, right? So 3 dimensions. And just doing that, like, kind of like blew their minds about it. We were saying, look, you shouldn't buy all this stuff the same way because it's not the same. But like what you're talking about when you add margin and all these other things, like an A SKU, however you want to define that, has got a lot of attributes, right? And if 3 is kind of blowing people away, I mean, you're talking about a lot of attributes to make up a certain kind of SKU. And it seems to me that's where sort of an AI type of system or approach is particularly valuable.
Yeah, I
Guys,
can.
go
Go
ahead.
ahead,
Sorry,
Dan.
sorry,
No, go
Fabio.
ahead.
Go
Go
ahead.
ahead. No, I was going to share an additional slide with you guys that I think it's valid for this discussion on the like clusterization. Okay, just let me share my screen again. Very fast, not going to take a while, but yeah. Do you see my screen?
It's yes.
It's coming.
There it
There
is.
you go.
Okay. So this one is a real example from a project that we built in the past related to we are trying to map what are the propensity of a specific SKU to actually have a stock out in the following 2 weeks, you know? And why? Because in that case, for that specific company, they had a very flexible manufacturing facility. So they could actually change their PCP, so their production control and planning or production scheduling. They could change it from one day to the other. It was very easy. So in that way, the short term variation on that supply chain was very valid and very valuable to them in order to reduce inventory stockouts, right? So those variables you can see on the right, so related to factory, what is the raw material? Is that a packaged SKU or not? What is the production time on inventory? What is the stock policy? Demand, what is the actually demand forecast accuracy? What is the actual demand? How much orders I have in hand or not? If there are promotions or not, and so on and so forth. So typically, when you address a supply chain problem, you actually run onto those variables, right? Run onto that data and try to model that, right? what we did here is that we transformed those data, those, let's say, time series, into variables that could be used to segment a specific product. For example, if I have a product or a finished good that has type A and B raw materials, that has a specific stock policy, that has typically a promotion in the end of the month, that has types of equipment that could have problems of breakdown into the production line and so on. Those variables were used to clusterize or to group certain products into one group or the other. And based on that, we could have a specific process or a different decision. For example, I would add a second supplier for a specific raw material because it's influencing a lot those SKUs that I'm losing sales, for example, because I don't have an inventory and so on and so forth. So that kind of thing, then I don't know if it's it helps or not, but
no, that's exactly the whole idea of clustering and using a sample of data, and kind of going back to your idea about these projects tend to be very iterative, right? Because you start off with kind of the ideate, like what do we think is causing the problem? Okay, let's go get a sample of data. Let's do some cluster analysis. What do we learn from that? Okay, what we sort of assumed this, but that's not really turning out in the data. But we're seeing this problem that we didn't really expect over here. So let's go get some more data related to that, right? And that's where this cluster analysis comes out. The other thing is that am I on the right track there? Yeah. So what's interesting about this is going back to my example, working through the board and with the management team. Part of we were approached by somebody who had an algorithm and was offering to just take a quick look. Culturally, though, the management team, when I brought up that idea, they said, "Well, but what are we going to learn?" And the answer was, "Well, we're going to learn what the data tells us." But I think culturally, because they couldn't really wrap their heads around what's the tangible business value out of the box, what can we expect to happen? Because they couldn't see it directly, they're just like, well, we can't do that. Where my view was, what are we going to learn? We don't know until we crack open the data, we run some numbers, and we get some initial feedback. What do you think, Fabio and Bill?
Yeah, I think a question back for you.
Yeah.
Have you heard the term data-driven consulting?
No, data-driven, you hear a lot, but data-driven consulting.
Yeah. So
I like to think that's what I do, but maybe I'm wrong.
No, it's like, Bill, it's like this is the difference between what we did until maybe 5 years ago and now, right? So what we did in management consulting 5 years ago is that you interview a lot of your clients, and then you, from that, combine with your expertise, because we always have some area that we know a lot and so on, in this case, supply chain. And then you come back with some hypotheses. Based on that hypothesis, you try to build up a solution, test it, and if it proves that those hypotheses are good or right, and then you go forward, right? So the data-driven consulting concept is like, okay, interview your client, okay, because you have to understand the business process and so on. But before build your hypothesis, take a look at the data.
Yeah.
And then using what you learn from the interviews and meetings with your client on the business, try to understand what the data is telling you. And that thing will bring you completely different hypotheses.
Yeah.
And from there, you build a model or solution, then turns back. And what it does to you is that it gives you factual visibility of the business. And typically you come back to your client and say, man, your data is telling me A, B, and C. And they are going to say, man, never heard of that. I was not thinking of that. And I come back into like maybe 20 years old project that I was in a retailer back here in Brazil. working with a COO, and then trying to better position specific SKUs into a store, a retailer store. They were focusing on a specific set of towels because it was like a fashion or Bed Bath and like Bed Bath from Beyond here in Brazil, right? And then we came back to say to them and said, man, this thing uh, has an inventory turn of maybe twice a year, so you're crazy. And then he said he completely changed their decision based on those analyses. It was not AI, it was not data, it was not statistics and so on. It was very simple analysis, but this is it. When you combine data with your business understanding and then then with the hypothesis, then it's a different story, man. This is exactly what you said.
Yeah.
I think the thing with the cluster analysis that I like is like there are some action items from those things, right?
Yeah.
And you run into people like, oh, well, what's the problem with this product? Oh, the supplier, they're very unreliable. That could be the main reason, but there are probably some other factors that play into that that's a little more nuanced than just the supplier is unreliable. And I think that's what's cool about that cluster analysis is it enables you to have some action items that'll really move the needle.
Yeah, and so that's to be fair to the management team that I was dealing with, these tools weren't available back then. We didn't know what advanced data analytics, but I think Fabio just said, hey, just in the last 5 years, there's been huge advancements that you can, instead of sort of like Fabio said, taking the traditional consulting, tell me about your problems, we'll come up with our own guess and we'll go to work on it. No, let's get a sample of the data and crunch the numbers and let that help us set the path. So with that, how about questions, gang? Questions from the audience. We've got like 24 participants in here, which is fantastic. While you're thinking about, feel free to drop in your questions. Let me do this. I'm going to go back. Let me just tell you just a little bit about the program. So we have the Master Supply Chain Transportation and Logistics program. It's a cohort-based program. It's all online. We have one live 2-hour session each week. You've got some advanced prep that you need to do in the program. It's very practically focused, right? We focus heavily on the case method. All of the professors have worked in industry and have a million stories about challenges that they faced and how they overcome those challenges. Kind of, if you're thinking about going into the program, we're going to give you strategies to help optimize operations, do quantitative analysis and methodologies. We're really stepping up that part of the program. One of the more interesting things that we get feedback on is the risk management and building resilience into the supply chain, which is a huge deal, right? After COVID, and now with all the tariffs, there's a lot of reshoring and onshoring going on. So how do you understand the risks inherent in that and build resilience into your supply chain? We're talking a lot more these days about data management and analytics, and then ultimately kind of trying to understand your supply chain from a 360 degree perspective. So we'd love to have you. You can go to the website. There's links there to apply if you'd like to do that. With that, are there any last questions as we come close to the end? I did want to mention that last week or 2 weeks ago when we prepped for this, Fabio was down in Brazil where it's summertime. Where are you, Fabio? He was at his beach house. Where's Fabio today? Fabio, where are you today?
I am in Orlando with the kids.
With your kids.
For vacation.
Going to Disney World. It's a tough life,
Yeah,
and Bill's down in Scottsdale where it's like 75 degrees and the rest of us bums up here in the Pacific Northwest are left with the gray and drizzly. So that's kind of painful. But Bill, Fabio, thank you. Thank you very much. Really appreciate the help. Fabio, I'm gonna go. I've got to be on campus this week, so I'm gonna go to the merch store and get you some stuff, and I'll ship it down here.
Yeah.
No, yeah, man, absolutely. Okay, Bill, Fabio, thank you very much, and our producer Katie, thank you for getting this all set up and managing the applications and getting this thing kicked off. So with that, thanks, gang.
Thank you, guys.
Have a great
Thank
day.
you.
We'll be in touch. All
Bye
right.
bye.
Okay.